Alright, so we're going to look at the pH scale. And the pH scale tells us if a solution is an acid or if a solution is a base. Now you're going to notice in this video we're going to talk about the same items, and there are a lot of common items that you have exposure to, like lemons, tomatoes, soap, and oven cleaners. Now we're going to divide our table from acids and bases down the neutral line. The neutral line is found at 7. Everything to the left of neutral is an acid. Everything to the right of neutral is a base. Now, acids all have H plus ion in common. Every acid has an H plus at the beginning. For example, hydrochloric acid. You're going to notice that there's an H at the front. Hydrochloric acid is found in your stomach, so it's up here in the stomach acid. Then we have OH minus ion. You'll notice that there's a minus symbol. That tells us it's going to be at the end of a compound. For example, NaOH, the OH is at the end. This is found inside oven cleaners. Alright, so let's take a look at the differences between acids and bases. Acids have a pH of 0 to 6.9, which means we're almost to 7 but not quite. These have our lower numbers numerically. They also have a sour taste. So, like citric acid, which we'll remember from our investigations, is found on Skittles and Sour Patch Kids and all those sour candies that you like. This sour taste comes from the citric acid, which is also found in lemons. Lemons is a natural source of citric acid. Another property of acids is it's corrosive. The word corrosive means to eat away chemically. We'll talk more about corrosive later. Alright, let's take a look at bases. Bases have a pH of 7.1 to 14. You notice we're still not saying 7. We're just slightly above it. They have a bitter taste. Think of the times when you're taking a shower and you accidentally got shampoo in your mouth. That is a bitter taste. They're slippery. So think of the shower analogy again. You're holding a bar of soap. The soap slips out of your hands. It is very slippery. Very high characteristic of a base. And they are corrosive, just like an acid. Alright, so we're going to break this down again. So we're looking at the characteristics earlier of acids versus bases. But let's take a look at acids themselves and bases themselves. They can be broken down even more. So let's start by drawing our line down the middle for our neutrals. Neutrals are exactly what you would think with the word. Neutral. Boring. Nothing happens. This is a cup of water. Pure water. Not spring water. Not mineral water. Water. It is very standard. Nothing cool happening with it. Alright. If we go to the right of neutral, we get into weak bases. Weak bases have low numbers of OH ions in the solution. So our weak bases include eggs and baking soda. Things that you've probably had in your diet at some point in time this week. Then we go up to strong bases. These have a large number of OH ions in solution. These are not good to eat. These are your heavy cleaners. These are the things that when you're working around your house and your mom makes you do a chore and you're having to clean, you need to put gloves on to do it. So like ammonia, bleach, oven cleaner. These are high corrosive items. Alright, let's take a look at the acids. Alright, so near the neutral line, just like with the bases, we got weak acids. These things include milk and bananas and things like that. Very low in the acidity, very low numbers of H plus ions floating around in solution. Then we got strong acids. These have a high number of H plus ions in solution. Now you'll notice that we have items like grapes and lemons in the strong acid section. So if you have an upset stomach, it is not recommended that you eat lemons or grapes because it's going to increase the acidity already in your stomach. So if you look, stomach acid is an acid. So if you have a high stomach acid problem, you want to come over here towards your weak bases and eat some of those items like eggs or some baking soda to help neutralize your stomach or Tums. So let's look at how to test for pH. What you're going to do to test for pH is you'll use these little strips of paper called litmus paper. And you'll notice that when you dip them into a solution, it can either turn blue or it turns red. If the litmus paper turns red, it means it's an acid, and if it turns blue, it's a base. So that's for litmus paper. Then there's another type of paper called pH paper. pH paper is totally different than litmus paper. Litmus paper only tells you if it is an acid or a base. That's it. pH paper can actually tell you, okay, if it's an acid, it's a base, and what exactly is it? Is it a 4 or is it a 1? Litmus paper will only tell you if it's an acid. It's not going to tell you if it has a pH of 1 or a pH of 6. But pH paper can tell you the actual level. When we discuss acids and bases, we're also looking at a type of chemical reaction. So on the reactant side, we have acids and bases, and on the product side, we have water and salt. So, as in our example earlier, we have hydrochloric acid, HCl, plus a base, sodium hydroxide. When you mix those two together, we're going to get salt and water. So our water compound is a standard H2O. The H comes from both the hydrochloric acid and the sodium hydroxide. That's where the two H's are coming from, and the O. So we have two other chemicals left. What are the other two chemicals form? Sodium chloride. And those two chemicals come from the hydrochloric acid and the sodium hydroxide. So they come over here to form HCl. Well, now, the interesting thing about acids and bases solutions is they always equal pH 7. So they always become a neutral solution. So we have a pH of 3 plus a pH of 13 does not mean 3 plus 13. It's okay, I'm at 3, I gotta go to 7. I'm at 13, I gotta go down to 7. It's kind of what's going on. So if I have a pH of 3 and a pH of 13 mixing together, I'm going to get a substance with pHs of 7. You notice the water and the salt have a pH of 7. So both of these items are neutral. So when you look back at the pH scale, you'll notice that pH 7 is neutral. All waters and salts are neutral.